Hello everyone, in this video you are going to learn about the concept of atoms. So first, atoms is what made up for our world. I mean everything, including this pen, you and me, all made up from atoms. Atoms, it got different size. For example, a hydrogen is probably this size, the potassium can be this size. It's quite big difference. But why? We're going to talk about this later in this video. So first, we're going to talk about those symbols. We got so many symbols for them, like hydrogen is H and potassium is K. Why? Potassium is taken from Latin names, which not from English, but hydrogen is definitely from English. Because I don't know why, just search online, bro. So now we talk about the atom structure. So when you see an atom, you usually see a nucleus and something around it. Like here's nucleus and something always go very fast around it. What is it? The nucleus contains two parts. One is called the proton and one is called the neutron. And the other part is called the electron. So for the proton is positive charge plus 1. And the neutron is neutral. There's no charge. And for the electron, even though it's so small, but it got negative charge. -1 actually. And the symbols for proton is P, for neutron is N, and for electron is E minus. And their weight, proton and neutron is actually almost the same because it's so less different, so we usually just the ratio for them is 1 to 1. But for proton to electron, the ratio is 1 to 1837. That's very high. And so let's move on to the element. For elements, it's got, and not God, it got so many of them, like hydrogen to calcium, potassium, bromine, bromide, iodine. But for exam, you usually need to remember 20, which is hydrogen to calcium. For details, I mean, just you can search online, there's tons of them. Just remember, first to the 20 is most important because that's what you need to remember, or you actually can just ignore them, not remember them. Yeah. And then we'll talk about the atom's structure, or I mean other atoms like isotopes. Like atoms usually, yes, naturally electronically neutral, whereas the proton is supposed to same as the electron. But for the neutron, it's just like a garbage, but it will cause something called isotopes. Like proton is not meaning the ratio to neutron is 1 to 1. Like for example, hydrogen is 1, but its electron is same, but the neutron is 0. So it's not meaning that the hydrogen got same number of proton and neutron. It's not true. But the different number of neutron also cause isotopes. That's what we're going to talk about, which means that its neutron number is different, so it got the same chemical properties but different physical properties, like the boiling temperature and when it's changed structure or something, but the chemical properties is always the same. Like hydrogen, we can get isotopes like 0 neutron, 1 neutron, 2 neutron. That's 3 different stuff, even though it's almost the same, but most common is 0 neutron, and most less common is probably hydrogen got 1 neutron or 2 neutron. So we want to talk about, yes, I pull up some graph here, and for proton and neutron in combined together, we can get the mass, and its mass and the number of proton, which is the number you see in the periodic table. Like here, I got a periodic table. You see, yeah, it's different number here. Hydrogen is 1 and helium is 2. So proton is what we call the what's where and how we line up them. But yeah, we're gonna pull up this graph and we can see actually there's a full symbol for it. The full symbol, how to read it is kind of easy. First we got a right hand side, we got a big symbol of it. That's what we call it, like hydrogen is H, potassium is K, calcium is Ca. And for the left side, we got is the upper one is the mass, the relative mass, which is the proton and electron combined together, and I mean the number of proton and number of electron combined together, and you get the relative mass. Yeah, relative mass. So yeah, if you got a periodic table, usually you can see the relative atomic mass, which is the upper one, or you can say relative. It's two different stuff, but upper one is always the mass of it, relative mass, and for the lower one, it is the atomic number, which used to line up for the period and those groups. So what and how to calculate the relative atomic mass, and what is relative atomic mass? So for relative atomic mass, it means, you know, isotopes, right? It got different mass. So we use that mass. That means the symbol and the upper numbers, the left upper corner numbers. So we use that to times the percentage of the abundance. I mean, there's tons of them, but you need to know how many of them are in the world. So you calculate the average of them. That's the weighted average. So after we got the weighted average, that means it's the relative atomic mass. First, the fun fact is that scientists use carbon-12 to calculate them as a unit. Yes. So now we can ask for what is the electron shell. Electron shell is easy to understand because it's something, as we talk about, it's wrapped around nucleus. Nucleus made of a proton and neutron. What about electron? Electron shell and the number of electron shell determine how big is this atom. As we just said, a potassium atom can be this big, a hydrogen probably just this big. There's a quite big size difference. Why? Because different number of electron shells. Electron shells can be calculated. As we know, all atoms should be electronically neutral. That means this electron, the proton number should same as the electron number. So then we can know how to calculate the number of shell. The formula is 2 times n to the power of 2. Yeah, I gotta show it in the screen. Yeah, and for a shell of it, actually just a concept. Yeah, and it's going to use later for like calculating the formula of it, and two chemical combine and react together, and what we got is all depends on those electron shells and electron. And also for electron arrangement, the electronic arrangement is easy to understand because we all know, and now we know what is a electron shell. So I need to drink some water. So after we know it's an electron shell, so we can know what is the arrangement of it. So as what I give you the formula to calculate the number of electron shell. First shell only got 2, second is 8. And also for those stable noble gases, because they're all in a duplex structure, which means only 2 electrons, or an octet structure, it means the outermost shell is 8. It is so stable, which is group 0. Yeah, I'm gonna show you on screen then. Group 0. Alright. Yeah, and it is the electronic arrangement. Like calcium and potassium, the fun fact is that it is not 2, 8, and then like less than. It can mean it's not 3, because on the first shell you can get 18, the maximum is 18, but for potassium and calcium is 2881 and 2882. So remember that if in exam it asks you about the electron arrangement for potassium and calcium, don't fucking answer it's got 3 shell only. It's actually got 4 shell. That's the end of this video. Thank you for watching.